Hey everyone, let's take a look at number 9 in section 4.1. We're going to consider this function here, and we're going to determine the linearization L of f, this function f at a equals 6, and express all numbers in exact form here. So when we talk about linearization, all right, you might have seen this equation in the textbook or even in my lecture video. I talked briefly about it, but really this is the linearization, but it's really nothing more than the equation of the line that is tangent to this function at the value of x really of equal to 6, right? When a is 6, and we talk about f of a, that's the point on the graph. So if I graph this function, whatever this function looks like, and we're trying to find the linearization at that point where a is 6. Again, this is not the graph of this function. I'm just doing an arbitrary graph. But something like this could be, the function f could look something like that. And then we're just basically looking at that line that's tangent. And you can see that tangent line near to x equals 6 looks very similar to the function. Far away it doesn't, right? It diverges, but real close. And so we can approximate the value of the function by its tangent line, and that's what we mean by linearization. So L of x is the y value, f of a is the y coordinate of this point, right? So we usually call the coordinates of this point a comma f of a, or I'll say x1 comma y1 when we're talking about the equation of a line. The slope m is f prime of a, and x minus a, or x minus x1. So there's our regular, just the equation of the tangent line. So how do we find that? We find the derivative to find the slope. So here's where calculus comes in. I've got to use what rule to find the derivative of this function? Hopefully you're saying quotient rule. All right, remember that's the derivative of the top over the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. So what is the derivative of the top function? Piece of cake, right? Derivative of x squared minus 8 is 2x times the bottom, which was x minus 3, minus the top function, x squared minus 8, and the bottom was x minus 3, so its derivative is just 1 over the bottom function, x minus 3 squared, right? There's the quotient rule. Clean this up a little bit, distribute the 2x through, and distribute this negative through. I get negative x squared plus 8, and then I can combine like terms. 2x squared minus x squared is x squared. So here's the derivative. Of course, I want to know what the slope is at what the value of a we're given is 6, right? So I'm plugging in at 6 to get my actual slope of 8/9. They want you to give the exact value. So there it is. And then the actual point x1, y1 is at x equals 6. And then the value of the function at 6, so just plugging 6 into the original function helps me to find the y coordinate of the point on the function. Right, so just plug in 6 into that function. We get 28/3. And so I've got y minus y1. So this is the value of x1, and this is the value of y1. 28/3 equals the slope m times x minus x1, or a. At then there's the equation of the tangent line. Solve for y now. Distribute the 8/9 through. 8/9 times 6 is 16/3, because right, you can divide both 9 and 6 by 3. So we get basically 2 times 8 is 16 over 3. And then I want to add 28/3 to 16/3. That gives me 12/3, or 4. So here's the equation of the tangent line. Of course, linearization is typically written at y as L of x, y is a function of x. And so here's the answer for that. Okay, I hope this is helpful on linearization. Nothing more again than finding the equation of the tangent line.